Hello everybody, welcome into another lesson. So today we're going to talk about linear functions. This shouldn't be a super long lesson and probably going to seem like review to most of you, honestly, of stuff we've covered, but it does need mentioning. Linear functions are equations such as f of x equals mx plus b. If we remember, you can interchange f of x for y. But I also did say let's get used to seeing f of x, because from here on out you're going to see a lot of function notation. So if you have them in the form of f of x equals mx plus b, that is considered a linear function. Linear, the degree of the equation is always 1. It's always to the x to the first degree. That's the highest degree of the equation, so that means the degree of the equation is 1. Now, it also comes from the name, where when you go to graph a linear function, you get a straight line. It's kind of in the name, line here, linear. So having said that, whenever you graph a linear function, you will get a line. And let's do some examples here. Alright, so let's say we have one such as g of x equals x minus 3. So we have g of x equals x minus 3. Well, I'm going to go ahead and draw my coordinate plane, because as it turns out we are about to graph this too. We're going to graph this function, and I'm going to show you what it means by linear. You'll see exactly why it's called that. So let me just put some sufficient plotting points here. Okay, just bear with me while I draw some sufficient plotting points. I doubt I need this many points, but I would rather be prepared, honestly. I like to have too much more than not enough. Okay, so we want to graph the function g of x equals x minus 3. Well, since this is a linear function, it's relatively easy to do. You need to find at least 2 points. My suggestion is going to be the y-intercept, which would be when x is 0. So first thing you're going to do is take g of 0. That'll give you your x-intercept. That'll give you your y-intercept, rather. When you have g of 0, now you insert 0 in for x, you'll have 0 minus 3. Well, g of 0 equals negative 3. So when x is 0, y is negative 3, so you get the coordinate 0, negative 3. So let me plot that point here. I think I'll do the line in green. Alright, so we have the point 0, negative 3 plotted. Now, the other thing, so we found the y-intercept. Next thing you want to do, find the x-intercept. You find the x-intercept of a function by setting the function equal to 0. So you'll take g of x, you'll set that equal to 0. Well, g of x is going to be x minus 3. So you take x minus 3, set that equal to 0. Well, then you would just get x equals 3. So when x is 3, y is 0. So you get the coordinate 3, 0. So what you're going to do now is you're going to plot the point 3, 0 right here. Now we've plotted our 2 points. All that's left to do is draw a line. Whoops, that's a horrible line I'm drawing. As I said, I'm not Bob Ross. Okay. draw a line through the points, connect the dots, and you have yourself a line. That is what the graph of g of x equals x minus 3 looks like. It's a line. And you see why it is called a linear function, because it's a line. Linear functions are probably the easiest ones to work with, to be honest. Now the next lesson we're going to do is quadratic functions. Those are a little bit harder. That's where we get into parabolas and stuff like that, but it's not so bad either. You'll learn tricks for dealing with quadratic functions and what to do with them and how to graph them. So, alright, put a line there. Alright, what is the next one we're going to do today? F of x equals negative x plus 1. Alright, so we have f of x equals negative x plus 1. We would like to graph this function. So how we're about to do that, once again, find your x and y intercepts. You'll find the y-intercept when you set x equal to 0. So if we take f of 0, that'll be equal to negative 0 plus 1, which is just 0 plus 1. So that means f of 0 equals 1. So when x is 0, y is 1. So you get the coordinate 0, 1. So let's go ahead and plot 0, 1 on our graph here on the coordinate plane. So there's the point 0, 1 right there. So we found the y-intercept. Let's find the x-intercept. And to be honest, you could put any value in for x you want and you'll get out a value of y. There's no rule saying you have to just stick with the x and y intercept. However, those are traditionally the easiest to work with. So that's why I would personally suggest you pick those. Okay. So now we want to find the x-intercept. We do that by setting f of x equal to 0, which f of x in this case is negative x plus 1. That'll be equal to 0, which means negative x equals negative 1, which means that x equals 1. So when x is 1, you get the y-coordinate of 0. So you also end up with the coordinate 1, 0. So we'll go ahead, we'll plot that where it goes right here. So we've plotted both points. Now all you gotta do is draw a line and connect them and go through them and you have a line. And this is a line with a negative slope because the slope in this equation is negative 1. So this is what a line with a negative slope looks like, but it's still a line nonetheless, a linear function. All right. What's the next one here? We have q of x equals 2 minus 1/3 x. So we have the function q of x equals 2 minus 1/3 x. Well, first thing again, let's find your y-intercept by setting x equal to 0. So to do that, you'll take q of 0. Well, that'll be equal to 2 minus 1/3 times 0. Well, 1/3 times 0 is 0, so you would get 2 minus 0, So that means q of 0 is equal to 2. So when x is 0, you get the y coordinate 2. So the coordinate 0, 2 is part of this line. So let's plot 0, 2. That'll go right there. So we found the y-intercept. Now we need to find the x-intercept. And in order to do that, you're going to take q of x, set that equal to 0, and q of x in this case is 2 minus 1/3 x equal to 0. Well, 2 minus 1/3 x equal to 0, that means that is 1/3 x equal to 2, which means x would equal 6. So when y is 0, x is 6. So you get the coordinate 6, 0 as your second coordinate for your x-intercept. So let's go ahead, let's plot 6, 0, which would go right about there. Now we just need to draw a line, connect the dots, right? And there you go. That is what the graph of q of x equals 2 minus 1/3 x looks like. All right. Now, what's the next one? We have d of x equals negative 3/4 x. So we have d of x equals negative 3/4 x. So once again, you'll want to find your x and y intercepts. Well, let's find the y-intercept first. You do that by setting x equal to 0. So let's take d of 0. That would equal negative 3/4 x. Oh, sorry, negative 3/4 times 0. Right? Okay, well, negative 3/4 times 0 is 0. So d of 0 also equals 0. So you get the point 0, 0 for the y-intercept. Alright, well, we'll go ahead, we'll plot the point 0, 0, which would turn out to be the origin. That'll go right there. Now, of course, you want to find the x-intercept, so you set d of x equal to 0, which in this case, d of x is negative 3/4 x. That'd be equal to 0, which means x equals 0. So you also get the point 0, 0 for your x-intercept. Well, we already have that point. So what do you do in a situation such as this? What you're going to do is just find another point. Find a point that's going to make life easier for you. I'm personally going to suggest that we pick x equals 4. Let's do d of 4. That's equal to negative 3/4 times 4, which means d of 4 equals negative 3. So when x is 4, you get the y-coordinate negative 3. So the coordinate 4, negative 3 is also another coordinate. So let's go ahead and plot that. Now we have our points. We can go ahead and draw a line. So that there's the graph of d of x equals negative 3/4 x. So if you come up with the same coordinate for both the x and y intercept, then just find another point to plot that would fit into the graph. Like if you pick x being 4, you come out with y being negative 3, so you could plot 4, negative 3. You could have done it with any other point too, but I'm picking points that's going to make life easier. As we all know, it's usually preferred not to work with fractions. If you can avoid working with fractions, why do that to yourself then? Why work with them if you don't have to? Okay. We have r of x equals negative 7. So this time we just have r of x equals negative 7. Well, what's true for r of x? That's also y. We have y equals negative 7, right? That'd be the same thing. Do we remember Vux Hoy? Remember the Hoy part. 0 slope, because there's no slope, y equals, it's a horizontal line. It'll be a horizontal line going through y equals negative 7. So let's go to 1, 2, 3, 4, 5, 6, 7. You would have the point 0, negative 7, and it would be a straight horizontal line continuing to infinity through the point y equals 7. That's what that would look like. If you want to graph r of x equals negative 7, you just get a straight horizontal line at y equals negative 7. And it goes on infinitely. So that one wasn't too bad. Whoops, wrong color. That'll go right here. What's next? We have n of x equals 0. So n of x equals 0. Well, n of x again is the same as y equals 0. Well, we have no slope. Remember the Vux Hoy, we have Hoy again. Y equals 0 slope horizontal line. You'll have a horizontal line straight through y equals 0, or in this case, it's the entire x-axis. I don't even need to draw that because the entire x-axis will be the graph of this one. So it'd be a straight horizontal line through y equals 0. Alright, what do we got here? I think we're up for 4 more. How about f of x equals 2x plus 10? So f of x is going to equal 2x plus 10. Well, let's go ahead, let's find the x and y intercepts. Start by finding the y-intercept. You do that by doing f of 0, which would give you 2 times 0 plus 10. Well, 2 times 0 is 0, so you have 0 plus 10. So f of 0 equals 10. So when x is 0, y is 10. You have a coordinate of 0, 10. Which, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's going to go right up about here. And now we want to find the x-intercept by setting f of x equal to 0. Set f of x equal to 0. Well, f of x is 2x plus 10. Set that equal to 0. Well, 2x would equal negative 10, which means x equals negative 5. So you end up getting the coordinate negative 5, 0. So actually, let's put that in green here. put that in green since that's a point. Here's negative 5, 0. Now you're just going to draw a line and connect them. And that is the graph of f of x equals 2x plus 10. All the way out here. So, again, finding your x and y intercepts, not so bad. Alright, let's see. F of x equals 3x minus 9. So we have the function f of x equals 3x minus 9. Well, let's find the x and y intercepts here. So, y-intercept, you set x equal to 0, so take f of 0. F of 0, that'd be equal to 3 times 0 minus 9. Well, 3 times 0 is 0, so you have 0 minus 9. F of 0 would equal negative 9. So you would get the point 0, negative 9 for that. So we have the point 0, negative 9. Let's go ahead and graph that, plot that. 6, 7, 8, 9. All the way down here, 0, negative 9. Then you want to find the x-intercept by setting the function itself equal to 0. So f of x equal to 0, which would have to mean 3x minus 9 equals 0. So 3x would equal 9. So x would equal 3. So you get the point 3, 0. So now we can plot the point 3, 0, which will go right here. Then we'll just connect these 2 points. And there is the graph of f of x equals 3x minus 9. Let's see here. Last one. Very last one. F of x equals 5x plus 8. So we have the function f of x equals 5x plus 8. Well, let's start out by finding the y-intercept. You get that by setting x equal to 0. So let's take f of 0. That'd be equal to 5 times 0 plus 8. Well, 5 times 0 is 0, so you have 0 plus 8. So f of 0 equals 8. So that means you get the point 0, 8. So that's one point you can plot is 0, 8. That's your y-intercept, which would go right about up here, 0, 8. So we found the y-intercept. Now let's find the x-intercept by setting the function itself equal to 0. F of x equals 0, which would have to mean 5x plus 8 equals 0. 5x plus 8 equals 0 means 5x equals negative 8, which means x equals negative 8 fifths. or that'd be -1 3/5. So you get the point -8/5, 0 for your x-intercept, which is about -1 3/5, which would be roughly right there. So now we've drawn both intercepts, we can draw a line. That's going to be a tough one to draw from this angle. Actually, what if, hear me out, what if we did that? There we go. And there is the graph of f of x equals 5x plus 8. So that's really all there is for linear functions. Next lesson will be about quadratic functions. So I hope everyone has a good night. Take care.